Zeros and negatives of indices. Zeros and negative indices. Well, this is a continuation of our previous lesson of the first 3 laws of indices. So if you have not watched that lesson yet, quickly go and watch it and come back and continue from this point. Well, before we look at the zeros and negatives of indices, let's refresh our minds a little on the first 3 laws of indices. Specifically, I think the second law that we discussed. And we'll use that to understand each of these. Yeah, negative and zeros indices. So 2 to the power 5 divided by 2 to the power 3. In our previous lesson, we said 2 to the power 5 is the same as 2 multiplied by itself 5 times. Divided by 2 to the power 3 means 2 multiplied by itself 3 times. But what do we do? Since they are dividing, the numbers cancel out. The 2 at the top from the cancel out. The next 2 cancel out. The next one cancel out. We did that in the previous lesson. So if you are lost, go watch that lesson. Our first video indices. Now, how many 2's do we have left? We have 2 left. So 2 times 2 is 2 to the power 4. So this is basically what it is. And then in that lesson, when we're talking about the second law of indices, we found a shorthand way of doing it. That if you are dividing numbers with the same base, for example, 2 to the power 5 and 2 to the power 3 have the same base, and that base is 2. The base is what? Is 2. It's only the powers that are different. So we found a short way of doing it. That is 2 to the power 5 divided by 2 to the power 3 is the same as 2 to the power 5 minus 3. 2 to the power 5 minus 3. So the powers, we subtract the powers. The powers are 5 and 3, subtract them. And that gives us 2 to the power 2. So you can see that this is a shorthand way of doing it instead of expanding and cancelling out. Good. So this is what we did in our previous lesson. This is when the powers are different. So this is what we do when we are dividing. Now I have a question for you. What about if the powers are the same? For example, 2 to the power 3 divided by 2 to the power 3. The powers are the same. What about that? Well, we will go through the same method and see. 2 to the power 3 means 2 multiplied by itself 3 times. Divided by 2 to the power 3 means 2 multiplied by itself 3 times, right? Good. Now what happens? 2 at the top 3, 2 at the top 3. So obviously, the first 2 and the first 2 will cancel, then this and this will cancel, then this and this will also cancel. So 2 divided by 2. 2 divided by 2, 2 divided by 2. For this, it becomes what? The numbers at the top. When they cancel out, they become 1 each, right? So it's the same as 1 times 1 times 1 divided by 1 times 1 times 1. This is simple mathematics that we learned in GHS, right? Then if you multiply 1 by itself, 1 times 1 times 1, you will get 1. Divided by 1 times 1 times 1, you get 1. So basically, it means if you should work 2 to the power 3 divided by 2 to the power 3, the final answer will be 1. I think that is clear, right? The final answer will be 1. But at this point, if you don't understand it very well, just drop it in the comment section. I'll reply to you, or maybe one of the students interacting with us in this video will reply to you. So now we get it, right? Look at this, 2 to the power 3 divided by 2 to the power 3. What about if there is another way of doing it? Remember the second law of indices when we said when multiplying numbers with the same base, subtract the exponents? Yeah, I'm sure you watched that lesson. 2 to the power 3, the base is 2. Divided by 2 to the power 3, it has the same base. They all have the same base and their base are all 2. So what that means is that you pick the base and you subtract the powers. So 2 to the power 3 minus 3. And 3 minus 3 is what? 0. So 2 to the power 3 divided by 2 to the power 3 is equal to 2 to the power 0. And 2 to the power 0 is equal to 1. This is what we refer to as the zero index or zero index, or zero indices. That's what we refer to as zero indices. Basically that. So look at this, 2 to the power 3 divided by 2 to the power 3. When we worked it out, we ended on 0. And if you use the simple rule of indices, that's the second rule, when dividing numbers with the same base, you subtract the powers. For this, the powers are the same, so it ended up giving us 0. So any number to the power 0 is 1. So that is the zero index law. And the zero index law, according to that law, any number raised to the power 0 is equal to 1, provided the base is not 0. You can't have 0 to the power 0. No, it has to be 1 to the power 0, 2 to the power 0, 3 to the power 0. So any number to the power 0 is 1. This is something you just have to keep in mind. So that means 2 to the power 0 is 1. 10 to the power 0 is 1. 100 to the power 0 is 1. 1,000 to the power 0 is 1. 1 million to the power 0 is 1. And a to the power 0 is 1, as long as a is not 0. X to the power 0 is 1. B to the power 0 is 1. So basically, the zero index law helps us to understand that any number raised to the power 0 is 1. I think that is clear enough, right? Well, before we move to the negative indices, I want you to analyze something. 2 to the power 2 is 4, right? How do we know 2 to the power 2 is 4? 2 to the power 2 means 2 times 2, and 2 times 2 is 4. Now, you see the power, let's remove 1 from it, so that it will now be 2 to the power 1. 2 to the power 1 is 1. It's 2. Now, let's take 1 from the 1, so that it will be 2 to the power 0. 2 to the power 0 is 1. I just want to build a point. 2 to the power 2 is 4. 2 to the power 1 is 2. 2 to the power 0 is 1. So you can see that for the powers, we kept going down and down and down from 2 to 1 to 0. From 0, where do we go? We go to negative, right? So 2 to the power negative 1, what do that give you? Do you know it? 2 to the power negative 1. What about 2 to the power negative 2? Yeah, I said, what? How do I do this? This is basically the negative index law. The negative index law. So, according to the negative index law, if you have a number to the power negative, what it basically means is that the factor becomes a denominator. Simple. It doesn't mean the entire number is negative. I repeat, a number to an index of a negative value doesn't mean the number is negative. It simply means that the factor you are considering becomes a denominator. Let me explain that. You see 2 to the power negative 1, it simply means 1 divided by 2. You see, the 2 becomes a denominator. So what it basically means is 2 to the power negative 1, remove the negative, right? Just remove it and write 1 divided by 2 to the power 1. But, 2 to the power 1, we can't write 2 to the power 1. Like, if it is 1, we do not write it when it is positive 1, unless it is negative. If it is positive 1, we don't write, so let's replace it with 2. So 2 to the exponent negative 1 means 1 over 2. Have I successfully confused you? If I've confused you, just write confused in the comment section. And then I'll take my time and give some little explanation to that. Or perhaps somebody will be able to explain to you. But if you're not confused or you understand, just write clear, or well understood, lesson clear. Yeah. What about 2 to the power negative 2? Now look at what that gives us. That gives us 1 divided by 2 to the power 2. So this becomes clear. So we have 2 to the power negative 2 is equal to the reciprocal. You pick the factor and you reciprocate it. So that's what you mean by in negative indices, factors move to become what? Denominators. Factors do what? Factors move to become denominators. So we have 1 divided by 2 to the power 2. So just remove the negative there, and if you remove the negative, it becomes 2 to the power 2, right? Then use it as a denominator. I hope you get it. So this is what we refer to as the negative index law. So we've seen the 0 and the negative, but there's one unique type of negative index. That is when what you have is a fraction. For example, 5 divided by 2 to the power negative 2. 5 divided by 2 to the power negative 2. For this, before I give you how it is done, let's solve it step by step and see. When it comes to indices, if you have a bracket and then there's an exponent or a power, that power affects each of the numbers individually. This is what I mean. Instead of this negative 2 affects the 5 and affects the 2. So 5 divided by 2 all into brackets negative 2 means 5 exponent negative 2 divided by 2 exponent negative 2. So the negative 2 will operate on the 5 and also operate on the 2. It operates on the 5 and operates on the 2. So with that cleared out, what we need to do now is to solve like normal, right? We already understand the negative index law. So 5 to the power negative 2, what does that mean? It simply means 1 over 5 exponent 2. If you remember our previous line, 5 to the power negative 2, it means what? 5 exponent negative 1 divided by 5 to the power 2. Divided by 2 to the power negative 2 means what? 2 divided by 2 to the power 2. Do you get that? We explained this on our previous line. And then simple division of fractions. What do? You write the first number, you change the divisional sign to multiplication, and then you reciprocate the number that comes after the division sign. You repeat your first number, change the division to multiplication, then you reciprocate the second number. You learn this in basic math in IGCSE, right? So 5 divided by 1 divided by 5 squared times 2 squared divided by 1 gives us what? 2 exponent 2 divided by 5 exponent 2. I think you got this. And then we see the 2 has exponent 2, the 5 has exponent 2, but we want to bring the exponent 2 out. So we can just rewrite this as 5 divided by 2 all into bracket exponent 2. Basically done, dusted, right? Done and dusted. So 2 squared divided by 5 squared is the same as 2 divided by 5 all squared. It's basically the same. But I want you to see something. Look at this. The highlighted ones. The question we have at the side there, 5 divided by 2 all into bracket is for negative 2. When we solve, we look at the answer we got at the end. You can see it's the same. It's basically the same. But the negative in front of the 2 has disappeared. And the number in the bracket 2 has been turned upside down. That's exactly what happened. So the negative index law, when it comes to fractions, and you have it, the only thing you need to do, remove the negative and reciprocate the numbers inside. This is not rocket science, we just need to know it. Oh, you see, we went through all this process just to land here. So if you have a fraction, exponent, a negative value, just remove the negative and reciprocate the number inside. So that means this number is the same as this. 5 over 2 into bracket negative 2 is the same as 2 over 5 into bracket exponent 2. And then 2 on 7 exponent negative 1 is the same as 7 on 2. Finish. Exponent positive 1, but we do not write the positive 1. What about this? 1 on 81. 1 on 81 exponent negative 1 over 4. Write in the comment section. I'm waiting for you. Write it. Yeah, you are done writing it. Yeah, it's the same as what? 81 on 1 divide exponent 1 on 4. Remove the negative and reciprocate what is in the bracket. So this is basically the zero and negative indexes. And I hope you enjoyed this lesson. And then this becomes a build-up on our previous lesson on the laws of indices. So we've gotten the first law, the second law, and the third law, the zeros and negative indices. So after looking at these laws, naturally our next step should be solving of questions. So we'll solve questions to help us revise on these laws that we've looked at. So see in our next lesson where we'll be solving a lot of questions. So if you have not subscribed to the channel yet, subscribe. subscribe, so that, and also put us on post notifications so I will not miss interesting, helpful lessons. And also share the video with other students you know will benefit from this lesson. So this brings us to the end of our lesson on zeros and negative indices. But a quick shout out to some of my students that I have. In our previous lessons, I think one of our lessons was on trigonometric ratios. I gave some assignments and some of them did amazing works. You can see that they've put a lot of effort into solving those questions, and I really appreciate you all. Some of you actually did Word format of the work. Some of you did PDF format. Some people went as far as write the entire question before answering them. I really appreciate all of you. And these students are Roy King. He did an amazing work. He sent to me on WhatsApp. We have Miriam, Vanessa, Geoffrey Osafo Osei. We have, his name is Icon. Yeah, then we have Sedem, Benjamin Ufuri. Then we have Kelvin and Hans. So this student did an amazing job by sending me their questions, the answers to the questions on trigonometric ratios. So I hope your efforts will be rewarded greatly and your performance in your final year exam will be amazing and you come up with flying colors. So see you in our next lesson.